Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The year 1869 witnessed a pivotal moment in the nascent field of chemistry, a moment profoundly shaped by the meticulous work of Dmitri Mendeleev. The relationship of the properties to the atomic weights of the elements offered not merely a table, but a revolutionary framework for understanding the intricate connections binding the elements. This essay delves into the genesis of Mendeleev's work, its specific methodology, its immediate impact, subsequent developments, and the profound legacy it continues to hold. Mendeleev's genesis was inextricably linked to a critical need. The burgeoning field of chemistry confronted a formidable challenge. The sheer number of known elements was expanding rapidly, yet their properties and behaviors remained scattered and unorganized. Previous attempts at classifying elements primarily focused on shared valence and atomic volume. These efforts, however, lacked a unifying principle, leaving the atomic weights and the myriad properties of the elements as seemingly arbitrary entities. Mendeleev, inspired by these earlier efforts, sought a definitive answer to this seemingly chaotic constellation of chemical entities. The core of Mendeleev's work lay in his meticulous examination of atomic weights. He recognized a recurring periodicity in the properties of elements as their atomic weights increased. This was not a simple arithmetical progression. Mendeleev's insight transcended mere tabulation and involved a profound comprehension of the underlying principles of chemical behavior. His method involved arranging these elements in a compelling tabular format, ordering them according to ascending atomic weights. He observed that similar chemical properties were repeated at regular intervals. This periodicity wasn't arbitrary but a significant pattern, a recurring theme with a fundamental role of arranging elements in this fashion. Specific properties like valence and reactivity exhibited a beautiful rhythm as one moved across the table. This detailed organizational structure facilitated the recognition of patterns not discernible before. The immediate impact of this groundbreaking work was extraordinary. Mendeleev's table, now iconic, permitted the accurate prediction of undiscovered elements. This is perhaps his most remarkable contribution. Precisely identifying the characteristics of yet unseen elements was truly astounding. He anticipated the existence of elements like gallium, germanium, and scandium, thoughtfully leaving gaps in his table, acknowledging that these missing elements would inevitably be discovered and would precisely fit into the patterns of the periodic table. This predictive power was nothing less than revolutionary, demonstrating the underlying order within the seemingly chaotic landscape of chemical elements. Subsequent developments built directly upon this foundation. Mendeleev's work became a cornerstone of modern chemistry, an inspiration for countless scientists seeking patterns and frameworks to understand natural phenomena. His periodic table became an indispensable tool, a foundational concept that continues to influence new discoveries within the field of chemistry, as well as related scientific disciplines like physics and materials science. The development of quantum mechanics provided further theoretical grounding for understanding the periodic table's essence, linking abstract notions of quantum numbers to the observed properties of elements, deepening the physical understanding of the periodic table's nature. Contemporary critiques of Mendeleev's work were inevitable. Questions arose regarding his choice of atomic weights, particularly for elements like tellurium and iodine, whose expected placement versus their atomic weights implied a paradox. This controversy highlighted the ongoing refinement inherent in scientific progress. Subsequent experiments and refinement of the measurement techniques resolved these issues, further solidifying the table's significance. This refinement underscored the inherently iterative aspect of scientific advancement and the rigorous approach required in seeking truth. Ultimately, Mendeleev's relationship of the properties to the atomic weights of the elements was not simply a tabulation of elements but a profound articulation of underlying principles. This work profoundly influenced the scientific community and is essential to understanding how science operates. His meticulous analysis of chemical properties, coupled with his pioneering use of atomic weights as a basis for classification, established a paradigm shift in the field, solidifying the periodic table as a cornerstone of chemical understanding and influencing research in subsequent decades and centuries. This table remains a pivotal figure in scientific history, serving as a testament to the power of observation, methodical analysis, and the relentless pursuit of order within the complex world around us. The meticulous work of Mendeleev stands as a vivid example of how a seemingly simple organization of information can lead to profound insights.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.